Hi, today we're going to take a look at number 6 from the homework set 3.1. It's kind of a long problem, so hang in there, and we'll hit many of the fine points of quadratics. So the first thing we're given is this quadratic equation, or function, and we want to use completing the square to write it in standard form. So they use a really cool trick. I hadn't seen it before this book. So what they do is they factor 2 out of the first two terms. Okay, so factored out that 2. And then the next thing they did was complete the square in the parentheses. Okay, so I have it set up. I'm going to be adding some value in the parentheses that it would make this factorable. And whatever I add in here, I'll multiply it by 2 and subtract it outside the parentheses. I can't add in something without taking it back out, without changing what function I'm working with. Okay, so completing the square. You look at the x term, and you do half of that. So 6 over 2 is 3, and then you square it, and I just kind of put a little bubble around that to say, hey, that was just my scratch work, but my result is that 9 is this number that was missing here. So 9 will go in the parentheses. But we don't want to subtract just 9, because if we took away 9 and we then went ahead and distributed the 2 into the parentheses, it wouldn't take away all of this. So we need to do 2 times 9, which is 18. Okay, so what we did, let's just put this here. We completed a square. In parentheses. Okay, so we need to just simplify. So we need to go ahead and factor and simplify. So f of x is going to be equal to 2 times this polynomial here, this quadratic, I can factor, and it's just x plus 3 squared. And then this is minus 5. So now this is in that vertex form. Okay. All right, so now they want us to answer some more questions about this. So what is the vertex? So remember, if I have f of x is equal to a times x minus h squared plus k, that's our standard form. I can line my equation up right underneath that. And then I can read off it what's h and what's k. So my vertex is -3, -5. Okay? Then we want to know, is this opening up or down? All right, so A is positive, A, remember, is this value here, which in our case is 2. So A equals 2. 2 is positive. So the parabola opens up. Okay. Then we want to know what's the axis of symmetry. Well, the axis of symmetry, that is just the x-coordinate of the vertex, written as an equation. So it's x is equal to -3. Okay. Continuing on, we could do x-intercepts. We'd have our function equaling 0. And what we want to do is solve this for x. So it's set up for us to use kind of the square root property, but we got to get rid of some of the stuff around the square first. So we'll add 5 to both sides. And then we can go ahead and divide everything by 2. Alright, and now we can take the square root of both sides. Remember, we have to do plus or minus on one of the sides. Okay. And when we do that square root, we don't want to end up with a square root in a denominator. So let's finish this first. So what I mean here is now this is like square root of 5 over square root of 2, and we don't like square roots in the denominator, so we need to rationalize the denominator. So I take that square root of 5 halves, and I say that's equal to square root of 5 over square root of 2. Okay, and what I can do is multiply square root of 2 on the top and on the bottom without changing the value, because square root of 2 over square root of 2 is just a 1. Alright, so I multiply those together and I get square root of 10 over 2. So I'm going to put this in a bubble, kind of like I did for completing the square. So that's like my side work. But my result is that I have plus or minus root 10 over 2 is x plus 3. And then I can subtract 3 from both sides. So here are my x intercepts. It would be at -3 plus root 10 over 2 and -3 minus root 10 over 2. Okay. They also wanted to know the y-intercept. And what we're going to do is replace x with 0. So we'll do f of 0 is 2 times 0 plus 3 squared minus 5. And when we clean this up, 0 plus 3 is just 3. 3 squared is 9. 9 times 2 is 18. So f of 0 is 18 minus 5. So it's just 13. So our y-intercept is at 0, 13. Alright, they also wanted you to look at the graph and the domain and range. So if we were going to graph this, they have you choose a graph. We're just going to sketch a quick graph. What I'm going to work with is the fact that I know the x-intercepts. I can use those if I want. I know the vertex, and I know that it opens up. So the vertex was at -3, -5. My axis of symmetry came down at -3. And I know that it opens up. Now, I could get more technical on where these x-intercepts are going to be, but I'm going to just sketch. Okay, so it's not going to be perfect, but it's going to be enough of a graph that I can pick out which one it works with. What I can also use this for is thinking about the domain and range. So domain for a parabola that's opening up or opening down, our domain is just -infinity to infinity. And our range, we go from bottom to top. So our first y value we hit is -5, and then it goes off to infinity. So our range is -5 to infinity. All right, that was a long one. I hope that this helps. Let me know if you need help.